irrigation, etc. And another thing, we have a crop insurance in Mauritius, and whenever there is like extreme rainfall, the farmers are paid a compensation. So having the highest rainfall statistics is very important, and it's being used by the stakeholders. Next, please. Then we have the temperature product, that is the maximum temperature, and also accompanied by, we compare it with a long-term mean about the anomaly. The number of warm days, this is quite important. Also, it's being used by the health sector, and some threshold indices at some location base. Next, please. Other product that's generated, for example, the sunshine hours, it's based on data that we collect from mostly, I would say, farming institute, and humidity also. This is very important, especially since one of our economy is based on sugar. So this is, they use it to calculate the sugar content and what the harvest is like to be. And finally, the windrows that we produce on a monthly basis, station-wise. Next, please. I was talking about the 3 monthly forecast. So this is basically based on the C4, and we have a Swayukov forecast that's being held every year. So using the technique of seasonal forecast, downscaling, and C4, we can have, I would say, a probabilistic approach toward the seasonal forecast for the next 3 months. So this is quite an overview how we put it in our monthly weather bulletin, and it's made available to all the stakeholders every month. Next, please. So now coming back to this project, you will find that even though a lot of things has been done, but unfortunately, there are gaps, and this is where this project is very, very important to address this gap. When we are talking about food security, water, the demand from the stakeholders, I would say, are justified in one way. And as a service provider, it's our aim to provide the best service so that the stakeholders can work in a very good way. So our goal through this project is to develop specific indices for the water reservoir management within identify catchment abstraction for irrigation. Met services cannot work alone. As I mentioned since the beginning, it's their cross-cutting issue. So we have partners like FARE and the Water Resources Unit who will be doing the presentation afterward about their demand, and this is where we are going to need forecasts for different basins on a monthly and 3 monthly period. So basically, this is what the project is. It may sound simple, but there's a lot of scientific work, validation of the product, etc., that has to be carried out before the stakeholder can use information, say, okay, this is within, I would say, uncertainty limit, and it can be used for the welfare of the public and socio-economic benefit of this country. Thank you. I think, yes, yeah, next, please, sorry. So, as I mentioned, talking about gaps and goals, so we have to improve the diversity, temporal and spatial resolution. That's going to, I would say, if we take into consideration Mauritius, the specificities of Mauritius, so this is going to be a challenge, but we hope that through this project and through the help of CSIR and all partners, WMO and our local partners, we are going to have some product which will improve, I would say, users, and they can use it for planning their work. And also, anything that happen, we have to have like a post evaluation. This also is included in this project. So yeah, I think next, please. Thank you. Just to note that I'm just one note is that I'm just stepping it for my colleague, Dr. Ram Dermia, who is unfortunately taken up. So he is the project lead, and I'm doing the presentation on his behalf. Thank you very much.
Thank you very much, Mr. Virasamy. That was a really nice presentation, to the point, and I think was excellent in helping to set the scene in understanding the context of Mauritius, the hazards, the products that are already being prepared, and the stakeholders and who they're delivered to. I think it was interesting to note that compared to yesterday, where we talked a lot about drought for Mauritius, and you can correct me if I'm wrong, but it seems like the challenge, or one of the major challenges, is actually extreme rainfall driven by the occurrence of cyclones, and something that needs to be taken into account of for forecasting in the country. I think you also mentioned the key crops, sugarcane being one of them, but there are also food crops that are important, and other aspects like crop insurance, which is not fully weather index based, but is still affected or needs some monitoring from the climate side for payouts. So thank you very much. We'll hold questions until all 4 presentations have been made. I would like to move on to our next presenter, who is from the Water Resources Unit, and that is Mahendra Kumar Biseswar. He is lead engineer at the Water Resources Unit in the Ministry of Energy and Public Utilities in Mauritius. His duties are related to construction, management, and operations of dams, including the conducting of environmental impact assessments. He's been already working jointly with MMS on hydromet-related projects, for example, funded by the Agence Française de Développement, and other technical projects related to SADC. He is also the ministry representative at the Irrigation Authority Management Board and the country representative at the SADC Water Resources Technical Committee. So thank you very much, Mr. Biseswar. You have 15 minutes as well.
Yes, good morning. My name is Mahendra Kumar Biseswar. Thank you, Sebastian, and thanks, Virasamy. And on behalf of my ministry, I'm here. It's a great opportunity for me here to be present and participate in this event. I've been participating several events, but this one is very important. And we are aiming to have some high objective. Especially this is there's a strong commitment by our management level and especially my director. So today in the presentation, I will be focusing on the water resources sector in Mauritius. I will give an overview of the select data about Mauritius and overall rainfall data. I will provide an insight of the organizational structure of the ministry. I will highlight some hydrological information, both surface and groundwater. Then I will talk about the current use of climate data and the challenges and opportunities. So as Mauritius is a volcanic island, is a volcanic origin. We have high permeability of rocks and groundwater, and most of our rivers radiate to the downstream to the sea from the central plateau. We have 2 seasons, which is a winter from May to October and summer from November to April. The wettest month is February and the driest month is November. And for February, March, and so on, we expect high rainfall for replenishment of our reservoir. And the 2/3 of the mean rainfall are harvested in the summer. And we have been very privileged to have an average rainfall of 2,000 millimeter per year. But sometimes we face some shortages of water in the dry months, as from September to December. We have also observed a great rainfall pattern, and this influenced greatly our water resources sector. So Mauritius, the area of Mauritius is 1865 kilometers square. It's very small compared to what I've heard yesterday about South Africa. Mauritius is a small island. With the rainfall pattern is about 1,500 in the east coast, 4,000 millimeter in the central plateau because these are high grounds, and 900 millimeter on the west coast. Our economy is diverse from sugarcane monocrop in the 1970s to the manufacturing, and now we are focusing more on tourism sector. Our population is 1.25 million in 2013. And just to add, we have approximately the same amount of tourists coming each year in Mauritius. Our access to potable water is 99.8%. The daily capita consumption is 180 liters. This is the map of showing the Mauritius rainfall, the long-term mean from 1991 to 2020. You can see in the blue is mostly the higher grounds where we have most rainfall in Mauritius. And on the western part, this is the driest place in Mauritius. And most of our reservoirs, impounding reservoir, are located in the central plateau in the blue area. This is a bit the variation between the summer rainfall and the winter rainfall. So we expect a lot of water during the summer because all this water contributes to the replenishment of the groundwater and surface water. But unfortunately, with the challenges we have in the winter, we need to better manage our water resources. I will talk about the unit that I'm working for. It's the Ministry of Energy and Public Utilities, the Department of Water Resources Unit. We are the apex body, and our responsibility, we have several stakeholders department, Central Water Authority, Irrigation Authority, Central Electricity Board, and the Wastewater Management Authority. Our vision is to ensure adequate and sustainable supply of water for the country's present and future needs. Our mission is to assess, mobilize, control, develop, manage, and conserve water resources and to supply such resources to stakeholders. Presently, we have 3 laws: the Central Water, the 2 laws: the Groundwater Act, the Rivers and Canals Act. Now, before coming, we are working on a new law, which is a Water Act. It's the first time in Mauritius since our independence or the creations, we had clusters law related to water. Now we are working on a water law, which englobes all the requirements the water sector in Mauritius. So we are responsible to administer any enactment relating to the water, which make provision in the enforcement and administration. So hopefully in the coming months, we'll be able to come up with a law and finalize the history in Mauritius. So we have also now a major hydrological catchment. We have 25 main catchment in Mauritius, and now we are investing a lot of money to update this information. We have LIDAR data, the new digital elevation model, where we are doing numerical analysis and all this catchment. So this catchment we are going to update, and presently we already done some of it, and the rest will be coming soon. So next is our minor catchment. Though it's small, very small, we have 26 small catchment, but we use this catchment to model any inflows to our reservoirs, to our system, and so on. And regarding one of the mandate of the Water Resources Unit is also to monitor and assess, collect the water flow in the river system. We have presently 106 flow measuring stations, 59 are equipped with continuous water level recorders, and the rest, 47, we have daily readings that we share with stakeholders. These readings are very important because we have also since a long time, that is up to 1960, the data. So we are using also this data to know a bit about the trend analysis and the climate change impact. Obviously, this we have noted tremendous change in the river flow in the last few years. So regarding the groundwater in Mauritius, it's very important to note that in Mauritius, 50% of our potable water comes from the groundwater. We are very fortunate in Mauritius to have clean water from the underground, and we have exercised a lot of control with regard to the abstraction effluent in Mauritius. We have 5 main aquifers and 4 secondary aquifers. And in fact, what I wanted to talk about on the left-hand side, what you see the cross-section, longitudinal and lateral cross-section. Mauritius is a volcanic island, has been formed with 2 volcanic eruptions. And then there was a collapse of the structure. That's why you see a bit the mountain range on the drawings, which is a green. These are the mountain range and so on. The main recharge zone is at the center. It's common to all over the island. So we are lucky that all this rainfall fall within the recharge area, and then we're able to abstract this water. But obviously during dry seasons, this impact on the supply of water. We have a law with the Groundwater Act that we administer and control all these activities with regard to borehole. We have 172 domestic and 226 industrial and 208 agricultural. It's very important to know that in Mauritius, if a planter wants to abstract the borehole water, is allowed to do it for his activities and so on, provided that is being done in a safe way. And in Mauritius, it should be located 1 kilometer from the high water mark. I'll just go back to one slide. You see the dark blue there. Mauritius is a small island close to the sea. We are impacting the climate change with the saline water intrusion. This dark blue is actually the saline intrusion zone in Mauritius. We have been able to map all this because we are doing regular salinity checks. So regarding our surface water reservoir, we have the main reservoirs that date back to 100 years. And the new reservoirs that are being built, we have 7 main reservoirs, 3 for hydropower, 2 for small private reservoir, and 10 hydropower stations. All these reservoirs are being done in Mauritius, especially the government has a strong commitment to invest in the water sector. We have been doing so much reservoir. In fact, unfortunately, the costs are very high, but we are committed to come forward with this project. We will be embarking soon a very big project with the Rivière des Anguilles Dam in the southern zone. We have been doing all the project in the central zone, but now we'll be supplying the south and the western coast, which is deficient in rainfall. So just a water balance for Mauritius. We have 3,776 million cubic meters of water. When we have an estimate of 60% goes to the surface runoff, 30% the evapotranspirations, and the net is 10%. This only 10% is the 50% of water that we abstract for potable use. So there's high scope for harnessing surface water. But unfortunately, with the evapotranspiration, we have been faced with a lot of challenge during dry period when we have to mobilize and water during the dry seasons. We expect we have so much evaporation and decrease in the reservoir water during this period. This is a table that we have for a bit to give a big picture of Mauritius, how we use our water for domestic, industrial, and tourism. Yes, it's 294 million cubic meters. Industrial is 9, agricultural is 305, and hydropower 389. What is very important, you see in the agricultural, it's 305 million cubic meters of water. You just see about our municipal water requirement is practically the same. But in Mauritius, the 305 amount includes 250 amount from private users. They have exclusive water rights in Mauritius. So we'll see in Mauritius, so it's a small island, we have so much water investing. Some people are having free water just for the irrigation. So with the coming in the new law, we'll be able to enforce all these restrictions and we'll be rationalizing this water use in Mauritius. So I will have last 3 slides to talk about this current use of climate services. Presently, we are collaborating with MMS to plan the operations and release of dam water and allocation to different water stakeholders. We have the seasonal forecast, and as and when required, they give us the information. Unfortunately, during the extreme seasons that my colleague has mentioned, the sea breeze, we have high rainfall, so we need all this information to manage our dam. During this season, during this situation, all our dams convert to flood detention basins. So we are managing also the flood during this season and so on. When we have deficient areas, we have been able to manage the water from different basins, which was not done before. in Mauritius. But now we are trying to have this water with feeder canals and so on from one region to another, especially where there are irrigation and so on purposes. The MMS also giving us some information about the trend analysis on the rainfall and the production of boreholes. And very important is that we have the National Water Resources Monitoring Committee, which is chaired by a ministry and involve all the stakeholders, the agricultural, CEB, and so on. Since we are the apex body, it is during this committee that we take decisions to allocate water in the different sectors, even in the private sector. This committee is very important. We have this committee on a monthly basis, but when there are dry periods, this committee normally we have this committee on a weekly basis or sometimes on a daily basis. So the challenges that we have in Mauritius is that what we have obtained, this is my personal experience because I've been doing for all these years in the sector, and that's why we are going to implement all these measures. We have observed a general rainfall pattern, change the rainfall pattern and the spatial characteristics. We have high intensity rainfall, but sometimes we have longer dry periods. And where we have our impounding reservoir, all this rainfall are falling outside this zone. Regarding the high intensity rainfall, we have been to be a bit wise to harness this water. We have been noting this trend and we have been building new dams within this region. And fortunately, this have been giving us good results because all this water was previously lost to the sea. We are also investing major projects in the drainage to harness this water. As I mentioned earlier, during the dry spell, we are doing the interbasin management. For regarding the data, we rely a lot on the MMS services, which they give us all the data. But on our part also, for doing construction of our dam, we're investing on automatic station and handing over to the MMS. We need to plan for the long-term food security. And obviously now we have the urbanization, land use change, and so on. So we need to rationalize these water rights. So the opportunities in this project that we will be focusing, maybe with further discussion with all the stakeholders, the climate change pattern, and the need for other observed data. Obviously, there is no MOU with the MMS, but within this project, it will be a good opportunity for us to work with an MOU and sharing of data and research. It's also important that whatever we'll find in this project, we on our part in the government, we try to invest if need be for some infrastructure if need. And then now we have the new satellite data that we don't use much in the water resources sector. For me, it's an opportunity also if there are ways and means to harness this information. And we need to be very resilient to the climate change impact because we are also doing parallel project with the hydromet services. We try to see how we can collaborate on these projects. Obviously, since I'm in the SADC committee, Water Resources Committee, there will be a chance that we'll be collaborating with other countries in the southern regions. And as I mentioned earlier, the challenges that we have in Mauritius is the sea breeze. So we don't have water. So we are facing this problem of sea breeze. And obviously the last two part is about the management, government decision. We obviously look forward to embark on very good strategy for this project and also to rope other stakeholders besides those who are mentioned in this committee. And for sure, this we will collaborate and give our assistance. Thank you.
Thank you very much, Mr. Biseso. Another very good presentation, a lot of contextual issues and also many issues around the needs and challenges. And following on from the first presentation, again, it was interesting to hear, despite Mauritius being a high rainfall island with periods of high intensity, not just high rainfall, but also high intensity rainfall, water shortages do occur sometimes during the year. Interesting to know that the Water Resources Unit is doing some inflow modeling, some dam management based on projections, I think what will be good to discuss is what kind of tools you are using. How much of it is science-based? How much of it is experience-based? I think that will be interesting to discuss with WEMC and CSIR. Also to note that water policy is quite important, given some historical context with private farms and those who have exclusive water rights at the moment. But going forward, there's need to rationalize that and enhance equity, something that we discussed yesterday. So thank you very much again for that presentation. I would like to move on to the next presentation, which will be from Mrs. Pratima Sichan-Punpun. Ms. Punpun is a senior research scientist at the Food and Agriculture Research and Extension Institute in the Ministry of Agro-Industry and Fisheries in Mauritius. She has a PhD in environment and works in the resource management division of FARE. Her interests and specialization include irrigation, fertigation, and climate smart water saving irrigation technologies. Mrs. Punpun, welcome. You have 15 minutes.
Well, good morning, everyone. Let's start with the FARE mission itself. The mission is to support and implement priority research and development training programs, projects, and appropriate technologies for food security and to enhance competitiveness, sustainability, and stakeholder equity across the agri-food value chain. Well, we have the crop research department, which had the responsibility to support and oversee development of the non-sugar crop sector and ensure that the needs of the sector is addressed through research and adoption of new technologies. Our mission is to conduct applied and adaptive cost-effective research for the introduction and development of novel technologies to increase crop production and improve crop quality to enhance food security in a sustainable manner. We have the livestock research sector, which comprises the animal production and animal health divisions. It has a mandate to conduct strategic research in the livestock and poultry sectors and adapts relevant knowledge and techniques to local conditions. The mission is to undertake applied and adaptive cost-effective research for development to boost up the livestock sector in order to increase milk, meat, poultry, and derived products and to enhance food security in a sustainable way. We have also the extension and training department, which ensures technology transfer to the farming community and agro-entrepreneur in the horticultural and livestock sector. Its mission is to provide a cost-effective technical advisory and training service to the farming community for sustainable development of the agricultural sector, vegetable, fruits, ornamental, and livestock. Well, the resource management itself, the main objective is to optimize use of agricultural resources, improve climate resilience, farm productivity, and maintain long-term sustainability of production systems. Well, under the resource management division, you will see that we have different sectors, that is the water and fertigation, irrigation, rainwater harvesting, the sheltered farming system. We work on quality declared seeds, the agroforestry, soil fertility management, climate change, composting, and agri-waste recycling, and new product testing. Well, let's have a brief introduction of climate change. It is happening at an accelerating rate worldwide. Climate change is intensifying the effect of extreme weather events and climate variability. As a small island development state, Mauritius is ranked as the 16th country with the highest disaster risk and the 10th most exposed to natural hazards. Hotter summers, flash floods, and damage to agricultural fields, crop and livestock after cyclones are more frequent in the island. Alarmed by the vulnerability of the agricultural sector in Mauritius to this global phenomenon, suitable adaptation and mitigation solutions have to be sought. Well, as per the Intergovernmental Panel on Climate Change, the adaptation is the process of adjustment to actual or expected climate and its effect in human systems. Adaptation seeks to moderate or avoid harm or exploit beneficial opportunities. And mitigation, a human intervention to reduce the sources or enhance the sinks of greenhouse gases. Well, the impacts of climate change in Mauritius are as follows. The average temperatures are rising. We have decreasing trend in annual rainfall, the sea level rise, lengthening of the intermediate dry season, shift in the start of the summer rains, and the number of consecutive dry days is increasing and number of rainy days is decreasing. The agricultural sector in Mauritius represent 2.78% of the GDP in Mauritius. Mauritius usually imports close to 77% of its food requirements. The main items imported include wheat, rice, oil, fresh fruits, meat, and milk. Over the last 5 years, the amount of imported has been going up, indicating an increasing dependency on imported food. Around 8,200 hectares of land are devoted to food crop production that annually aggregate to 110,000 tons. Agricultural production is undertaken by a relatively large number of small producers and the corporate sector. Some 8,000 small farmers cultivate a range of food crops, and a small number of farmers grow fruits for the export markets. Well, now let's move to the change in crop and livestock sector in Mauritius. Well, as we said earlier, the temperature rise will definitely create a shift in agricultural zones for some crops grown under rain-fed conditions to higher altitudes. The cropping calendar, flowering and fruit setting and production of some vegetables and fruits are affected. The production of some crops like onion and potato, which require cool temperatures, can also be affected. Crop cycles can be shortened, resulting in a reduction in yields. The higher temperatures in summer and lower temperatures in winter favor the incidence of pests and diseases. The crop production is affected by more frequent and severe agricultural droughts, cyclones, and torrential rains. Crop cultivated along the coastal belts are affected by more frequent tidal waves, which damage the soil quality and reduce productivity. We have also the incidence of flash floods, whereby the fields are waterlogged, soils become compact, causing asphyxiation of the root zones, soil erosion, loss of topsoil, and increased siltation, and also the crops are uprooted. Rain-fed regions are severely impacted. Water scarcity disrupts irrigation and water management. When increase in torrential rains lead to soil erosion in cultivated slopy areas, resulting in a reduction in soil fertility and increased impact outside the agricultural zone. Well, now let's have a glance at the livestock sector. Adverse effects on animal production are linked to thermal stress, reduced feed quality, water shortages, and cyclonic conditions. The temperature rise definitely will lead to reduced milk production, decreased productivity in chicken farms and increased mortality rate, lower pasture in production in rain-fed regions, and higher incidence of pests and diseases. The effects of cyclones will definitely cause damage to pens, increase mortality, and animals will require more attention. Well, now let's move to the crop management. Slide, please. Here you will see different water and energy saving irrigation technologies, whereby we tend to use new innovation for growers, whereby the irrigation time is decreased and yet the whole plot is being irrigated in shorter time. And we have the executive tube application system with its porous pipe. We have the nano spray irrigation and the nano drip fertigation system, along with the solar power driven drip fertigation system. These are new systems that have been designed in Mauritius, and we are actually doing the installation in our stations first and then moving to farmers' field. We also have some growers also have multi-sheltered farming, and at the same time, they are trying to decrease the incidence of pests and diseases as compared to growing crops in the open air. Yeah, you will see that the rainwater is being collected in a water tank, and the water is being used for irrigation purposes in sheltered farming. You will also have a look that we are planning to install 10 new automatic weather stations on all our stations. And we also have developed a climate smart rainwater harvesting structure, which will be going to be mounted in different stations to collect the rainwater and to irrigate our plot of land for agricultural purposes. These two projects is being implemented at present. And we have to come up with introduction and evaluation of new crop varieties, breeding of new varieties. And for greenhouse also, we have greenhouse production, we have to come up with new varieties of crop which can tolerate the heat stress, high salinity, and disease resistance. Soil moisture conservation measures is very important one. We should do minimum tillage, that is minimize soil disturbance so as to reduce evaporation, removal of weeds, we prevent competition for water and nutrients. We should use natural mulch, which reduce 50 to 80% water loss through evaporation from soil surface. Here we have a picture of rainwater harvesting in ponds and from rooftops. And we should come up with integrated crop management, as you can see from the picture here. We also have to come up with fertilizer management when we can use the manure, composting, and bioproducts. The livestock sector, we should modify the environment to minimize heat stress. We should provide adequate and good quality water, promote further production and feed supplement, advise on improved livestock housing, improve design of feeders to stimulate feed intake, improve diet energy specification for broiler, addition of vitamin C and betaine to alleviate heat stress in poultry, lower stocking densities to minimize the mortality rate, provide better quality feed, and breeding for breeds resistant to heat stress. Other measures are as follows: shifting to cropping seasons, no plantation in January, February, March, as they are high-risk months, shifting crop cultivation from lower lands to higher lands to temperature change. We have the calamity schemes to farmers such as the ACAS, compost subsidy scheme, the rainwater harvesting scheme, as I mentioned previously, awareness and training of farmers in disaster management, and installation of the 10 automatic weather stations over the island to cover the agroclimatic data, along with our meteorological stations. And we should promote growers to adopt the sustainable agricultural good practices. And I've come to an end of my presentation. I would like to thank you all for your attention. Thank you.
Thank you very much for a very interesting presentation. I really liked all the visuals and graphics. I think it's something that we need to improve on in all our presentations. It was nice to see actual pictures of the impacts and also pictures of what can be done and not just words. So that was a really interesting part. I tried to take some notes of highlights from the presentation, but it was really so rich with so much information. It was good to understand that there are various hazards in addition to drought, the effects of cyclones, but also heat waves, flash floods, tidal waves. I'm not sure whose domain tidal waves falls under, whether that's a geological issue. In terms of climate change, there's rise in temperatures, shift in seasons, overall reduction in rainfall, and number of rainy days, all with impacts on agriculture and livestock production. In terms of food crops, I understand onion and potato are important food crops, but with rising temperatures, these could be highly impacted. And at the same time, livestock as well, because of temperature stress, mortality, pasture quality issues, and pests and diseases. But it's also good to see that there are many technologies that can be used to make the sector, agriculture and livestock, more resilient. Sheltered farming, rainwater harvesting, resilient infrastructure also came up, and also enhancing the agroclimatic data that is available. And it's a discussion we've had with other countries. So, for example, making sure that any automatic weather stations that are installed have soil moisture and temperature sensors, wind at 2-meter height. This is something that you can adopt. At least the Met Services, I hope, are adopting in their countries. So thank you again for that very interesting presentation. Our last presentation, we'll try and bring it all together now, given this context, the discussions we've been having in the team, with the stakeholders, with the users, and with the service provider. What next? What exactly is the case study about? What will it be doing? We know what the case study is about, but now we want to try and hear some of the specifics. And that presentation will be made by Mohau Mateisi, who works for CSIR here in South Africa. Mohau is a theoretical physicist by training, quite interesting. His research interests involve understanding atmospheric processes over the Southern Hemisphere, particularly the drivers of climate extremes using numerical model simulations. And within Focus Africa, he's the lead for case study 8. So welcome, Mohau, to give us to bring it all together and tell us, with all this information, the needs, the challenges, the available technology, where is this case study heading? Thank you. You have 15 minutes.
Thank you very much, Sebastian. So we have had from the we have 2 presentations from the end user perspective. I think what is interesting from what we had from the water resource unit is a perspective on how delicate the system from Mauritius is when it comes to the water resource management. And I think it's important to take note of the fact that for them to optimize the water resources management, the next one, yeah, they have to take into account okay, back. Yes, they have to take into account the fact that now there are groundwater resources as well as underground resources, and depending on the climate circumstances, the nature in which it is being utilized and managed has to be controlled such that you avoid things like salination and of freshwater resources. So the objective of my presentation today is to just highlight how all the role players in this case study actually plan to work together to address specific aspects that we think can be informed by seasonal focus. So perhaps on the side of the agri sector, I think it is important also to realize that there's already an extensive amount of research in Mauritius that goes into resilience building. And what we do in this case study is trying to align with areas that we think the seasonal focused information can help. And what we learned in particular was that when it comes to the monitoring and decision making that follows some of the extreme events, it is important to have a rough idea of how the weather is going to look like at seasonal timescales. So, and we basically, the way we work as the CSI and OMC, we try to come up with possibilities of addressing or coming up with the desired data. We test first, and then we basically shift the developed capability to MMS so that it can interact. MMS can interact directly with the end user and fine tune whatever we get to a level where the information generated can be useful to the end users. And all this effort has to be coordinated, and it has benefited extensively from WMO, especially during the time of the pandemic. So perhaps to step back and just remind you some of the things that have been highlighted in the two presentations about the context of Mauritius. Next slide. So yeah, so Mauritius Island is relatively small. In fact, if we look into the numbers that Virasamy presented, is even roughly around 1.8 thousand kilometers square. So this is a very small region where if you were to try to do a forecast at roughly around 50 kilometers, you'll probably have maybe 1 point. And if you are interested, for example, for application, which are mainly at cropping area level or at catchment level, then more has to be done to come up with information that is downscale to relevant resolution. So perhaps it's important to recognize that also the climate in Mauritius is such that you have humid summers at temperatures around 24.7 degrees in summer, and also winter relative to summer is not very cold like most regions in the southern hemisphere, but there is a difference in terms of the precipitation patterns when you move from summer to winter. And one of the things that have been highlighted is that there is a noticed significant warming trend over the island, as well as a decline in precipitation. And this makes climate services innovation very relevant when it comes to management of the water resources for both food security as well as for other uses. So perhaps I should, next slide, please. Perhaps I should highlight that. So to overcome the challenges that have been emphasized around getting information at relevant scales, at relevant decision-making scales. So this case study set out to come up with an improved spatial resolution of seasonal forecast. Probably you've seen the forecast that Virasamy showed there at a fairly cost resolution for some of the desired applications. So our goal is to try to see if we can take advantage of the extensive station network over the island, and also the modern downscaling techniques, and come up with a resolution that could be improved relative to what we already have. And then the goal is to also advance the climate services that would better inform the water and agri sector. So in the end, we're going to walk away with some tailored products that are going to meet these two key sector usage. And of course, in the process, we have to think about how to promote uptake of these products that would be developed. So the co-design and interaction in the process of coming up with the specific products is very important as an approach that we are taking. And this also helps us to actually, as we go around, map up the socioeconomic benefits of whatever that would be developed. So these are the objectives that are actually targeted. And perhaps maybe next I will summarize how we are trying to organize ourselves so that we basically can achieve these objectives. So the workflow that we started with, I've talked about it earlier on, but I'll repeat some of the salient features of this. So we are basically starting on the part of the CSIR with and WIMSI with working with the algorithms for downscaling. So we started with dynamical downscaling with using WAP model. And then we are basically also planning to further downscale from the dynamical downscale model now bias correct or further statistically downscale so that at least we can enrich the data with what we can uplift from the observations. So we have actually mapped out specific requests for various users that we interacted with in Mauritius. So this include mostly standard meteorological parameters that would be availed through a seasonal forecast. But also the idea is not only just to generate them at high resolution, but also to make sure that we map to specific identified area that the end user would inform. And in the process, we'll basically discuss with in a consultative process in terms of how do we ensure that we provide the parameters that are specific to the sector. For example, we are talking with the water resource unit around how to uptake this information that would be in a form of probabilistic forecast. Also with the food security sector, we're actually trying to also fine tune in terms of what specific parameters would be relevant to inform, for example, the sugarcane farmer, as well as aspect of monitoring that are undertaken by the Food and Agricultural Research Unit. So the way of communicating information is also being discussed. For example, we are trying to come up with an end-to-end design that will actually fit from the algorithm into a visualized tool. So in this case, WIMSI is actually exploring the TIL tool, which is internally developed to see if it can actually fit into MMS infrastructure for communicating climate information and forecasts. Thanks. So perhaps just to showcase some of the initial inputs that we did. So with WAF, we started testing it in terms of downscale seasonal forecast to a higher resolution. So we went as far as roughly 0.4 kilometers. And the idea here is to explore various input models. Various input models in terms of coming up with a better characterization of uncertainty that is sitting in this product. So I'm not going to go into details about these considerations, but just to show that at least we have started, and this setup has already been established on the MMS side. So in parallel, as we test the physics schemes and all those, we keep on having exchange of information between the research partners as well as the service provider. Slide, please. So this is a precipitation output that was developed also, and the way forward is to test this and compare against observations which are presently being quality control on the MMS side. So we hope to be able in the end to come up with a probabilistic forecast. Next. Perhaps to summarize, what we did was basically to do the setups, to discuss ways to verify these forecasts against observations, as well as to map how we're going to come up with probabilistic forecasts, as well as their bias correction or statistical downscaling. Maybe to showcase one workflow that we looked into closely is also to basically integrate station observation, 3D dataset, and quasi-observations, and consider an ecosystem of statistical models that we can actually train and then apply on the simulation output so that we come up with model prediction downscaling. And this has been a work that has been published by Badia and appears to be ideal when one is aiming for an end-to-end design of a service that is developed from this kind of workflow. So in the end, this is basically a show of what WMC has started exploring in terms of how to visualize these outputs. And the idea now, because we're thinking of an end-to-end design, in the end, we can also use probably cell phone or web app visualizations that would probably be accessible to both the food security as well as the water as well as the water sector. Perhaps we should also acknowledge that in Mauritius, there's also an investment in terms of using cloud computing resources in this, and communicating information that is derived from these research innovations. And so in summary, I think I would say what we are planning to do is to finalize the model configuration and then evaluate the scientific rigor of the approach that is being taken, and then go ahead into the development of seasonal forecast products prototype and tailor them for the sectors that we have identified. And of course, in the end, we are going to integrate this into a workflow that will allow visualization. I think with this, I've more or less covered an idea of what we would like to achieve in this case study. Thank you very much for your attention.
Thank you very much, Mohau. Very nice presentation. And firstly, to say, going back to the mission in Mauritius, we were quite impressed with the way you came up with this framework with the colleagues at MMS in just a few hours after discussing with the stakeholders and displayed it on the drawing board. It was really impressive, and I'm glad that that has really translated into some. You really know the steps that you need to take and the direction that the case study is going. And looking back even further, 6 months, when there was real uncertainty on the direction of the case study and to where we are now, it's quite impressive. To highlight just one or two issues that, apart from the technical aspects of the case study, I think you've highlighted that it's quite important to continue the discussion and collaboration with the users, FARE and WRU who are in this room, but others from Mauritius where possible. And that will enhance the tailoring, the uptake, the use, and also feedback on the products and tools, something that I think is quite valuable for MMS. Another aspect that WMC is bringing to the table is the visualization, which I think is key for a number of the case studies, because fine, you can have products, information, data, but visualization and how that information is shared with the stakeholders and users is crucial. I think for Tanzania, Malawi case studies as well, this is something that needs to be looked into. How are the products and services visualized? So thank you very much to all the presenters. They were really interesting presentations, and I think we've done quite well with time. We are going to have 15 more minutes for any questions from the room, from those online as well. You can raise your hand or put a question in the chat. I open the floor. Any questions, comments?
Thank you very much for all the presentation that have been made. My question is going to the acting director from Mauritius. In his presentation, he mentioned the weather insurance as a part of the areas as the service they are supporting. So I would want to find out from him what role is the Mauritius Med Service playing in the weather insurance. And what is this insurance covering? Is it only food security, energy, or maybe it is encompassing? And further to that, I would also want to know what data set are they using in order to define a trigger that would determine the payout for that weather insurance. Thank you very much.
Sami, would you like to answer that question?
Yes. Is it okay?
Yes,
Can I
go
answer?
ahead.
Okay. So thank you very much for the question. So coming to the crop loss, actually it's an insurance for crop loss. It's called a crop loss insurance. It's target small farmers whenever there is a, I would say, high intensity event where the farmers, have some problem where they lose their seedlings and things like that. So there is sort of compensation that is given by the government to the farmers. But to calculate if the farmer and I would say not really the farmer, but the area of farming should be given compensation, this is where the Met services come into play. They need the rainfall data and the rainfall intensity data for that region, as well as other parameters, sometimes like wind, to ensure that yes, really that area under farming was under the influence of extreme weather, which causes a loss, and the farmer should be compensated. So this is a scheme under the government that started a few years ago, and we have one representative of the Met Services present in all committee for the assessment of which region to provide meteorological data. If I hope that answer your question, or is there anything else?
I think
Yes.
it's okay. Yeah, maybe just to say, I think I did mention that it's not entirely index-based. So if that is correct, but it relies on a combination of factors, including assessments in the field as well.
Yes, you're right. Thank you.
Thank you. Good morning, colleagues. I'm Charles Seola from Lesotho Meteorological Services. Mine goes to Verasami. With the implementation of processes such as QMS and frameworks such as Global Framework for Climate Services, I believe MMS has improved with time and are ready to provide user-oriented climate services. We have seen an example of food and water security. But now the question is there a time when you gauge your level of services by means of maybe surveys and verification of seasonal forecasts? Thank you.
Okay, thank you very much for the question. As you have rightly mentioned, so the Mauritius Meteorological Services is ISO certified, I think, more than 5 years ago, or even more. And so to be ISO certified, you have to do a lot of, I would say, homework in a way that you have to conduct surveys, liaise with the stakeholders. So every year to get our ISO certification up to date, you have to do a customer survey. So this is in line, and as well as you have to do a different kind of analysis like SWOT analysis, do an audit, etc. So that was for the first thing. And the second part of the question, it addressed, can you repeat the second part, please? Hello?
Maybe verification of seasonal forecasts.
Yeah, okay, sorry. So for the seasonal forecast is that it's true that we issue a seasonal forecast, but after every season, we have a summary, a report of how the summer was and how the winter was. In a way, it's a verification of our forecast. Also, it has an added advantage that, for example, when we go towards seasonal forecast, we have access to a lot of meteorological data from global producers of long-range forecasts, from regional indicators, etc. So sometimes it gives an indication in such and such. For example, when you have La Nina, which index works better, or when you have Enzo, etc. So this comes from the verification that we do after each season. Moreover, we have I would say, a monthly verification of all our forecasts. So verification is part and parcel of the work that's carried out at the Met Service. That's answer.
Thank you. There's a question from Violet has a microphone already.
Okay. Thank you very much. Good morning, everyone. I also have a question to the acting director of MMS. I was interested in knowing on the flow of information, especially in issuing of these extreme weather events. We've already heard that Mauritius is greatly affected by the extreme weather events, probably because of the tropical storms or cyclones that are happening near or around the region. So I was just wanting to know the flow of this information when they are issuing these warnings. Thanks.
I hope you got that, Mr. Virasamy.
No, I didn't got the last part.
I believe it's about the flow of information. How do you make sure that the information gets to those who need it, especially in terms of the warnings for aspects like cyclones?
Thank you. So as the meteorological services, we have like a dedicated system, which is called an automatic message switching system. So whenever you have a bulletin, it's at one touch, it's being sent to a priority list, starting from the Prime Minister's office down to the all hotels and stakeholders that have communication with the Met Services or has requested this service. At the same time, all information are transmitted in real time through media, and especially we have the national TV, which whenever we need to, to flag out something that's going to happen, we just call them and do live intervention on TV, on radio, and on our website also. Last year, we have, I would say, another step has been added. Now we have sort of a WhatsApp group for the media, for the local coordinators, and for the government official. So even though that we are sending the information through, through mail, through fax, through radio, they're also getting the message on their mobile via WhatsApp. And the next step is that the government of Mauritius is planning to install a new system called eWash. So by this, everybody will be getting their warning via SMS. Wherever you are, if you have a SIM card which is registered in Mauritius, you're going to get the warning on your mobile phone. So these are ways that we communicate, and it's something that we know. If you have a lot of information, good information, if it doesn't go to the public, to the stakeholders, it's no use. So we spend a lot of, I would say, energy and time to ensure that our stakeholders receive the information in a timely fashion.
Thank you very much. I have a quick follow-up question. How do you manage the cost implication of SMSs? Do you have partnerships with any telecommunication service providers?
Yes, so as I mentioned, for the SMS, this is a project in the pipeline. It's going to be, operated. Basically right now, all the hardware is being installed and the software, etc. And for the cost implication, it's going to be a public-private partnership at the level of the government. So unfortunately, being a technical guy, it's very difficult for me to answer the question, but it's a public-private partnership. This is to ensure that there is no loss in life and destruction of property.
Thank you, very interesting. Any other questions, comments?
To our stakeholders, to Rishi and Miss Pumpum.
There's a question. So one on the side.
Good morning. I just wanted to find out, looking at Mauritius and CSIR, in terms of how they're handling the data availability. I don't know, maybe for Mauritius, it might be a special case, but I've noticed that a lot of member states, when it comes to data, we have challenges. So I was wondering, are you going to be blending this data, or your data is in a good quality that you don't need to also go back to satellite data to improve the data quality? Thank you.
Maybe that goes to CSR and MMS. Maybe MMS could start. Mr. Virasamy.
Okay, thank you very much. That's an excellent question. Data is like, as you know, it's whatever you put in the system, the results is going to be an output of the quality of data. So what we have been doing for some time now, as I'd say for the past 10 years, we have been basically homogenizing all the data. And we are working kind of backwards. That is, data are in the system, they are quality control, but now we are going a bit further. We are using the WMO guidelines to homogenize, to ensure that the data is something that can be used, is useful, and has, I would say, a very low uncertainty or low margin of error. So the data set that will be going in this project has already been quality controlled and homogenized.
Okay, Mohau?
Yes, thanks. I think as Virasamy highlighted, there's an extensive amount of work that goes into ensuring that we have a usable data. Perhaps maybe just to highlight that in terms of our workflow, what we decided to do is to start with a few catchments where we have data that has been prepared. And on the basis of that, we'll start testing algorithms and working on that data to see if we can get it downscale in a reliable manner. So, and going forward, the idea is that the rest of the data that would have been processed on the MMS side then will be rolled into applying or deploying those capabilities that would have been developed in downscaling. So it's going to be a phased process as opposed to waiting until we have all the data before we could start our development process. Thanks.
Thank you. We'll take one last question. Okay, if Shingi wants to. All right. We'll take this last question and maybe a final comment from Shingi, and then we close the
Thank you so much. My name is Margaret Mzirai from Tanzania. My question goes to one who presented about management strategies using solar power drip irrigation. I'm just curious to know if they have information on the cost benefit analysis regarding to this technology to see if farmers can adopt this technology or not. Thank you.
Thank you. A very good question.
In fact, we just started with this particular project, and we are installing these systems at our station first to see whether it is beneficial or not. And once we got all data, required data, we will move on to farmers and to come up with the cost of production, the economics of it, and so on. We are on the working on it. Okay, thank you.
Thank you. Also, just to mention that the question came from Margaret from the Tanzania Agricultural Research Institute. Their center that she works in focuses on sugarcane, and there were a lot of, when I was there, I saw some sugarcane breeding, correct? A lot of interest in synergies with the work that's done by MCIA in Mauritius, and I think they're already working together. So maybe there are some other opportunities for discussion on shared learning around climate services for different aspects between your centers. We are out of time. Maybe one last. Well, yes, one last comment from Shingi, and then we close the session.
Yes, thank you. I just wanted to quickly point out one important factor for our case study, the Mauritius case study. we find that in Southern Africa, actually, there's a problem in data sharing. You know, the med services are not so willing to share the data for research and so forth. But then for our case study, the Mauritius case study, they are willing to share the 150 stations that are existing in Mauritius for us to evaluate the models that we are using. So I just wanted to point out that things.
Thank you very much, Shingi. Yes, data sharing is an issue, and I think there are many discussions, not just for Africa or Southern Africa, but globally on this issue and how Met services share data. And going forward, all stations, automatic weather stations that are installed, if they're sponsored by projects or by WMO, how do we ensure that that data can be accessed and shared? And I think it's quite an important issue. So thank you for that. Please, a big round of applause to all our speakers. Thank you very much. We are breaking for tea. We'll have a bit of a longer tea break than was initially planned. We'll come back in 30 minutes. So we'll break up until 11. Correct? Yes. And then I think there is already some word that has got out, but we would like to have a small discussion with some of the farmers who are here. Just to discuss some visualization issues regarding the forecast. That will be led by Alberto and Ilaria, I believe. So please, if you could take your tea or coffee and go with them and sit in one of the rooms. Alberto, will you lead us? Okay, thank you. So thank you very much. We meet up at 11 o'clock.